The Wright brothers, the aeroplane. To fly as easily and effortlessly as a bird is an age-old human dream. A dream which came true thanks to two brothers from Dayton, Ohio, Wilbur and Orville Wright. A dream realized without the benefit of a formal scientific education. From earliest childhood, Orville Wright was fascinated by experiments and mechanical constructions, a passion he shared with his elder brother Wilbur, who was never happier than when he was studying tables and theories. Both men harbored the vision of human flight. The Wright brothers' first powered plane looks far removed from the modern-day jet, but their basic attributes are the same. Orville and Wilbur had mastered the fundamentals of aerodynamics, flight control and propulsion. The Wrights succeeded where all others before them had failed. History is littered with the names of inventors, scientists and adventurers who tried in vain to outsmart the laws of physics. In the 15th century, Leonardo da Vinci sketched a contraption with flappable wings which he reckoned could raise a man into the air and propel him forward like a bird. His flying machine was never built and wouldn't have worked anyway. In the 18th century, the British inventor Sir George Cayley made the first systematic study of aerodynamics. He even managed to build gliders capable of undertaking short flights. At the end of the 19th century, Otto Lilienthal in Berlin took up where Cayley had left off. His design models were storks, whose curved wing surfaces he'd identified as one of the reasons for their elegant and effortless flight. Lilienthal's observations provided him with the key to mechanical flight, which he backed with theoretical explanation in his book, Bird Flight as the Basis of the Art of Flying. He was the first person to show that the curvature of the top of a wing needs to be more pronounced than that of the underside. It works like this. Because the air streaming over the top of the wing has further to travel, it flows faster than the air passing underneath. The result is a partial vacuum, which literally sucks the wing upwards. This upward force, called lift, is what keeps an aircraft in the air. Lilienthal conducted his glider experiments from an artificial hill at Lichterfelde near Berlin. And it was here on the 9th of August 1896 that the intrepid aviator was caught by a fatal gust of wind. Out of control, he crashed and sustained severe injuries. He died the following day, leaving others to finish the work he'd started. At the turn of the century, Wilbur and Orville Wright were running a small bicycle factory in Dayton, Ohio. Several years earlier, they'd turned one of its workshops into a kind of aircraft development lab. The brothers had developed a passionate interest in flying after reading of Lilienthal's work, and in the course of their studies discovered that the German had got his sums wrong. In fact, it was probably a design error due to an incorrect lift calculation that had cost him his life. Orville and Wilbur decided to ignore all existing theories about aerodynamics and start from scratch.
That's why we have the bicycle, because we should check every single profile.
Using simple test apparatus, they ran trials on various shapes of wing. The bicycle wheel served as a measuring instrument. The control shape was a straight, flat section. On the other side, they mounted a model of the curved wing profile they wanted to test for lift.
Okay, that's it.
So much for the theory. In practice, the Wrights first had to generate a continuous airstream for their comparative tests. As bicycle manufacturers, though, they didn't need to look far for a solution. Mounted on the handlebars of a moving bicycle, the wheel enabled them to compare the performance of each curved profile with the known characteristics of the control plate and thus identify the most favourable shape of wing. A simple but laborious process.
Good luck, old boy.
Okay.
In time, the Wright brothers could predict the amount of lift produced by around 200 different wing sections at any angle of attack. Their findings furnished the first reliable data on the principal laws of aerodynamics. The Wright Cycle Company in Dayton closed down for the winter. Its owners had taken a momentous decision. After encouraging experiments with kites, Wilbur and Orville now wanted to build a large glider, their first real vehicle for controlled manned flight. Carrying materials, tools and personal baggage, they set off on the long journey to the Atlantic coast, where they'd found a test site promising favourable wind conditions, near Kitty Hawk in North Carolina. This is where the Wright brothers were to make engineering history, at a remote and Spartan camp surrounded by sand dunes. Kitty Hawk, the world's first airfield. In the very first trials, in which Wilbur and Orville took turns at the controls, the glider flew for hundreds of metres. Their calculations had been correct. The glider's controls worked exactly as the brothers had anticipated. Unlike later aircraft, it had the elevator mounted at the front, so to modern eyes it looks as though it's flying backwards. The work at Kitty Hawk was a success, despite many crash landings. The Wright brothers now knew what their next step must be. Their glider needed an engine. And there was no time to lose. In 1903, Samuel Langley of Washington, their closest rival, was getting a machine called the aerodrome ready to make the first powered flight. Langley's aerodrome was driven by a 52-horsepower petrol engine, a recent development from Germany, and was to be launched by catapult from a barge on the Potomac River. On the 8th of December 1903, press and public awaited the launch with bated breath. In a derisory tone, the New York Times said it looked as though the world would have to wait millions of years for a machine genuinely capable of powered flight. In fact, it had to wait just 8 more days. Kitty Hawk, North Carolina, on the Atlantic coast. The Wright brothers had returned here after 9 months in Dayton. With them, they brought their new Flyer 1, aerodynamically tuned in a homemade wind tunnel. On the 17th of December 1903, Orville started up the plane's 12-horsepower engine and took off on the first controlled powered flight in history. It lasted exactly 12 seconds. On the very same day, the brothers undertook 2 more flights. The longest lasted nearly a minute, and the plane covered a distance of over 260 metres. In the years that followed, the Wrights improved their now patented Flyer and developed a plane they could keep in the air almost indefinitely. In 1908, Orville and Wilbur travelled to Europe to present their flying machine to an amazed public. Only then did the world fully realise that these 2 enthusiasts from Dayton, Ohio, had made man's age-old dream of flying come true. The Wrights' greatest achievement lay in discovering how to steer a plane in the air. With few modifications, the flight control methods they devised are still used today. Pitching, turning the plane about its lateral axis, was performed in Flyer 1 by extending the forward elevator. Modern aircraft have the elevator at the tail. For rolling, turning about the longitudinal axis, the Wrights designed a foot-operated mechanism for twisting or warping the wings in flight. And yawing, or turning the plane about its vertical axis, was performed by operating a rudder at the rear. In practice, the three manoeuvres rarely occur in isolation. To maintain flight stability, a plane generally has to bank in order to change direction. For any manoeuvre, even today, velocity, inclination of the aircraft and angle of attack of the wings have to be precisely coordinated. Otherwise, the airflow at the wing will break away and there'll be no lift. And if that happens, the aircraft will go into a spin from which it can only be recovered by a proficient and cool-headed pilot. Skill and steady nerves were certainly prime requirements for the daring young men and women who flocked to the new sport of flying at the beginning of the century. Before long, though, military minds were also alerted to the possibilities of the aeroplane. The First World War saw aircraft go into series production. What had essentially been a toy turned into a deadly weapon. Dogfights raged in the sky and bombs wreaked havoc on the ground. In the post-war world, the aeroplane developed rapidly into a useful means of transport. Civil aviation blossomed, extending a net around the world. Many of its first services were run or sponsored by postal administrations. Delivery times for long-distance mail were dramatically shortened. In the mid-20s, passenger airlines appeared on the scene, carrying the first human payloads. For the well-to-do, this opened up lots of new travel destinations and literally broadened their horizons. The world had suddenly become a much smaller place. In the late 1920s, a monoplane made the first non-stop Atlantic crossing. It was piloted by Charles Lindbergh, seen here on his arrival in France. Less than 3 decades later, Atlantic crossings were a routine occurrence. The travel wave rolled. On board the large propeller-driven craft, Mr. and Mrs. Joe Public caught their first scent of the big wide world. Today, they also perceive the negative effects of their seemingly boundless mobility. High energy consumption, noise pollution, and presumed damage to the stratosphere, mounting threats to man and the environment presented by an ever-increasing volume of air traffic. But aircraft are not just polluters. They're also useful tools for monitoring the environment from the air. Here, a reconnaissance plane spots a ship dumping waste in the North Sea. Policing work like this would be hard to do by any other means. Nowadays, the arguments for and against the aeroplane are finely balanced. But one thing is certain: flying has lost none of its mysterious fascination. Yet, wouldn't it be wonderful to go back to those carefree days when the dream of a lifetime came true for 2 passionate young men from Dayton, Ohio, the brothers of the wind, Wilbur and Orville Wright.